Hi everyone, in this video we are going to discuss about modern trends in power system production. So in that we are going to discuss about introduction of modern trends in power system production and gas insulated substation. So that is one of important thing in module 5. First we will see the introduction of modern trends in power system. So coming to the introduction, so in previously what we are doing, so we are controlling the devices individually. So we are not controlling the at common. So here what in modern power system production, so we are going to control the all equipments in one place. That is all interconnecting several individual controllers. AC network is a highly complicated network. So each individual controller AC network has its own generating station, transmission, distribution and load. So individuals if you consider, if you substation, so it has own devices. So individual network, if you consider, it has own generating station, like one station, and transmission distribution systems and loads and load centers. So here so in modern trends what we are going to do, so we are going to control all the equipment in at one place. So easy to understand, easy to control, so that we are using this network, but it is very complicated. So but is very complicated but easy and smartness. So we have to controlling all the equipments, all the devices at one place. The interconnection of different load centers located in different areas is necessitated by increased power demand. So by increasing the power demand, so we have to control these devices. So like a grid. So if you take a grid, so grid is interconnection of various power generating stations and power transmission lines. So like that, so if you have some grid connections, so we can control the which power station, which power transmission line is failed to supply the power. So easily we can understand, easily we can monitor, so easily we can find out the fault and easily we can rectify. So that is the one trend, that is the one technique in modern power system production. The regional and load centers controllers the generation in its own graphical region to maintain the system frequency between 50.5 Hz to 49.5 Hz. So the in frequency is constant in AC power supplies. So frequency if varies, the speed of the alternator will is. That's what we are doing. So commonly what we are maintaining the frequency range is 50.5 Hz to 49.5 Hz. And next one, gas insulated substation or switchgear. So gas insulated substation is one of the modern device. So only few places we are using this gas insulated substation. So in previously what we are doing here, conventional air insulated transmission and conventional insulated distribution substations we have. So those devices depends on air air blast, air brake, circuit breakers we are using. But in modernized, so we are using SF6 sulfur hexafluoride gas circuit breakers we are using. That's what those circuit breakers we are calling it as a gas insulated substation. So gas insulated substation consisting of following parts. One is SF6 circuit breaker, SF6 gas we are using, SF6 circuit breakers we are using, and bus bars, isolators or disconnectors, circuit breaker, current transformer, earthing switch. So these are the five equipment we are using in the gas insulated substation for production of equipments. And we will see the advantages and disadvantages of GIS, gas insulated substation. So gas insulated substation compactness, it will be very small. So air if you are using, we need to have air compressor, that is large equipment in power system, large equipment in substation, and also it will gives more noise. But if you use SF6 gas, so no need of air compressor. So that is that's what is very compactness, cost effective, protection from pollution, reduced insulation time, superior arc interruption SF6 gas, and reduced switching over voltages. So increased safety. So these are the 7 advantages in there. So it is a compact, size wise very small, cost is less, and protection from the air pollution, noise will not be there. So reduced insulation time. So since it has less number of equipment, then you can installation time is reduced. Next one, superior arc interruption. So within a fraction of seconds, SF6 gas will interrupt the arc, and reduce switching over voltages. So voltages oscillations will be less. So increases safety. These are the advantages. But coming to the disadvantages, GIS has high cost compared to conventional outdoor substations. So since so we are using all modernized equipment, so the cost of the substation will increase. So requirement of cleanliness in GIS is every strengthened, as dust or moisture can causes internal flash power. So you have to monitor dust and moisture should not enter into GIS, otherwise it will become a dangerous. Since GIS are generally indoor, they need separate building, which is generally not required for conventional outdoor substation. That is the one disadvantage here. So conventional substation not required separate room for installing installing the air compressor, but here it's required some separate building. So to avoid dust and moisture, and GIS can have expensive uh, uh, GIS can have excessive damage in case of internal fault. In case of internal fault, it is excessive damage. Okay. And next one, maintenance of adequate stock of SF6 gas is essential. So once the SF6 gas is over, so the equipment will not work, right? That's what adequate stock is required, and procurement of gas and supply of the gas is problematic. So it is very dangerous. Safely we have to transmit, so from that place to our substation place. So that is one major disadvantage in GIS. So so wherever the place is small, and if wherever the modernize is required, there we can use this GIS, gas insulated substation. So okay, so this is about modern trends in um, power system production. So okay, thank you everyone. Right. So okay ma, thank you once again, thank you everyone.